So the first thing we're going to talk about today, one is what is the zero exponent, right? What does that mean? Now, there's a couple of different ways to talk about this. One way I like to do is if I have, like, say 3 to the third, 3 to the second, 3 to the first, 3 to the 0, right? What is happening here each time? So if I look, 3 to the third is 3 times 3 times 3, which is 27. 3 squared is 9. 3 to the first power is 3, right? So what are we doing here, right, each time? If you notice here, each time we're dividing by 3. So right away when you get to 3 to the 0 power, what would that be? Well, 3 to the 0 power, or 3 divided by 3, would be 1. So basically anytime we see the 0 power, right, what we're basically getting is anything to the 0 power will always equal 1. So what would 3x all to the 0 power be? 1. What would 4 to the 0 power be? 1. Anything to the 0 power is 1. Okay, now the next one is basically the negative exponents, right? What happens if we get a negative exponent? Well, if you take that same scenario, right? We said 3 to the 0 power is 1, and each time we're dividing by 3, what would 3 to the negative 1 be? Well, if I take 1 and divide it by 3, I would get 1/3. Well, isn't that the same as 1 over 3 to the first power? So what happens is, if I look here, if I have x to the second over x to the fifth, right? If I subtract, I would get x to the negative 3. But we don't like negative exponents in math, so what do? Well, if it's in the numerator, to make the exponent positive, we bring it down. Now, I actually like the cross-out method. If I have x squared on top, that gives me 2x's, right? And if I have x to the fifth on bottom, that gives me x to the fifth, or x times x times x times x. And if I cancel these out, what am I left with? I'm left with 3x's, where at? On bottom. So it would be 1 over x to the third. So anytime we get negative exponents, remember, if they're positive, you move them, or sorry, if they're in the numerator, you move them down, and if they're in the denominator, you move them up. So the next one, if I have x to the fifth over x to the sixth, I could subtract those if I wanted to and get x to the negative 1, but then I have to know that I have to bring that to the denominator to make that positive. But what I like to see is 5 on top, cancel them out. Cancel 5 off the bottom, what do I have left? X to the first on bottom, so it's 1 over x to the first. So the next one, x to the seventh over x to the ninth, cross all 7 x's out. Take 7 off the bottom, what are you left with? X squared, so 1 over x squared. Okay, now, when we look at this, right, if I had x to the negative 18, I would have to rewrite that as 1 over x to the 18th. X to the negative 6, 1 over x to the 6th. Now, hypothetically, I'm going to go another example down here. If I gave you 1 over x to the negative 4, to make that positive, I would bring it up to get x to the 4th. Here, if I have 4 on top, 10 on bottom, I can cancel 4 out. How many would I have left on bottom? 6. So 1 over x to the 6th. Here, I have 3 on top, 8 on bottom, cancel 3 out. If I take 3 off the bottom, I have 5 left, so 1 over x to the 5th. Okay, so let's look at all of the properties we've done. Product of powers. Same basis, right? When we multiply, yesterday we said we would add the exponents. So 5 to the 2 plus 6 would be 5 to the 8th. If you do that in the calculator, it's going to be a really big number, so just keep it as 5 to the 8th. The next one, we know product of powers, same basis, multiply them, y to the 4 plus 3 plus 1 will give me y to the 8th. Down here, multiply the coefficients together, 7 times 6 is 42, then y to the 5th times y is y to the 5 plus 1, which will give you y to the 6th. don't make the mistake of adding 7 and 6. Remember, you're still multiplying numbers, but when you multiply same bases, you add the exponents. Example 4, negative 3 times 5 is negative 15. X to the second times x is going to give you x to the 2 plus 1. Then y to the 7 plus 6, which gives you negative 15, x to the third, y to the 13th. Quotient powers, again, we talked about this. If you have 6 y's on top, 1 on bottom, I can cancel 1 out. What do I have left? 5 up top, so y to the 5th. 6 to the 13th over 6 squared, right? I can cancel out 2. If I take 2 off the top, what do I have left? 6 to the 11th power. And the last one, I'm going to reduce this. I'm going to divide both of these by 5. When I divide both of them by 5, I get 2 over 5. Then I cancel out 5 a's, and I have 2 left up top. Cancel out 4 b's, I have 5 left on top. And I am done. Okay. Now we said anything to the 0 power is always going to be 1. So when I take this quantity and raise it to the 0 power, equivalent to 1. Now here on the other hand, I have to do 8 times x is the only thing being raised to the 0 power. So that becomes 1, and 8 times 1 is 8, plus 5 would give you 13. Alright, here 2 to the negative 3 would be equivalent to, make that exponent positive, 1 over 2 to the third. And that's going to be the same as 1 over 2 to the third is 2 times 2 times 2, which gives me 4 times 2, which is 8. So 1 over 8 is what this would give you. Now, negative 3 to the negative third, 1 over negative 3 to the positive 3 now, right? And in this case, I would get 1 over negative 3 times negative 3 times negative 3 is going to give me 1 over negative 27. So negative 1/27 is what you would get. Power to a power. X to the second to the 8th will give you x to the 16th. Boom, done. Remember, multiply the exponents. Y to the negative third to the negative 4 is y to the 12th. Right? Done. Now the power of a product. Here, in this quantity, everything is being raised to the third power. So, 4 to the third, x to the 3 times 3 would be x to the 9th, y to the third, z to the third. Now remember, 4 to the third is 4 times 4 times 4, which is 16 times 4, which is 64. So this will give you 64, x to the 9th, y to the third, z to the third. And you are done. Alright, the next one. Raise everything to the negative 2 power. So 7 to the negative 2, x to the negative 2, y to the positive 4. Now remember, if you have right now, this is technically a fraction with everything over 1. If a base has a negative exponent, we have to get rid of the negative exponent. Since 7 to the negative 2 is up top, to make that exponent positive, we bring it down. X to the negative 2, to make that exponent positive, we bring it down. But y to the 4th is already positive, so we keep it up top. And that would give me y to the 4th over 7 squared is 49, x to the second. And we are done. The next one, I'm going to get 6 to the negative 2. X to the negative 6 to the negative 2, multiply them to get x to the positive 12. Y to the positive 14. Remember, z to the 0 is just going to be 1, so it kind of goes out of the way. This is a fraction over 1, so now 6 to the negative 2, that's got to go down to make that exponent positive. X has a positive exponent, so it stays. Y has a positive exponent, so it stays. So we would get x to the 12th, y to the 14th, all over 6 squared is 36. Done. Okay. Next one. Here, what I like to do is just take and rewrite it as 3 squared over 5 squared. That gives me 3 times 3, which is 9, over 5 squared is 25. In example 18, we're going to raise everything to the exponent 2. So, 2 squared. A to the 5th to the 2nd, I multiply to get A to the 10th, over B to the 7th to the 2nd is B to the 7 times 2, which is 14. So 2 squared is 4, A to the 10th over B to the 14th. And we are done. Example 17, you're going to get 3 to the 3rd, A to the negative 12. Remember, we multiply the exponents here over B to the 21st. Now, 3 to the 3rd is going to stay and become 27. Since A has a negative exponent, right now, to make that exponent positive, it's going to go down to the denominator. Then B to the 21st stays, so 27, A to the 12th, B to the 21st. Done. Example 17. When I look here, everything's getting raised to the negative 6. When I raise powers to powers, I multiply. So A to the negative 2 times negative 6 is positive 12. B to the negative 5 to the negative 6 is B to the 30th. Then C to the 66th power. This cannot be simplified anymore. Alright? Now we're going to do a couple more examples here. Right? And I'm going to give you something like x to the 4th, y to the negative 2, z to the 3rd, all over x to the negative 5th, y to the negative 10th, z, like such. So write this down at the bottom of the notes, pause the video, and then come back and let's take a look at it. Anytime I get problems like this, the first thing I do is get rid of negative exponents. And I go and I start by saying, is x to the 4th going to stay or go? Remember, if it has a positive exponent, it stays. Negative exponent, it goes. So, x to the 4th is going to stay. Y to the negative 2 goes down and becomes positive 2. Z to the 3rd stays. X to the negative 5th, now that's going to come up to make that exponent positive. Y to the negative 10th comes up to make that exponent positive. And z stays. Now, to simplify this, I look at my x's. Both bases are up top. So I'm going to multiply them and say it's going to be x to the 4 plus 5. So x to the 9th up top. So y's. If I look, I have 2 y's on bottom, 10 on top. I can cancel 2 out, which leaves me with 8. And where do I have those 8? Up top. So it's y to the 8th. I have 3 z's up top, 1 on bottom. I can cancel 1 out. How many do I have left? 2. And both of them are up top. If I have nothing left in the denominator, I just leave it as is. Okay? So with a lot of these, remember, positive exponents don't move. Negative exponents go up or down. So when I look at the last example here, if I did something like a to the 3rd, b to the negative 6, c to the positive 2, all over a to the negative 5, b to the, negative 2, c, all raised to, say, the 3rd power. So a lot of you guys like to simplify the inside of the quantity first, but I'm going to advise you to raise everything to the exponent 3 first. Right? So a to the 3 times 3 would give you a to the 9th, b to the negative 18th, c to the 6th. Remember, power to power, I'm multiplying exponents. Do the same for the denominator. It's going to give me a to the negative 15th, b to the negative 6th, c to the 3rd. So now what I want to do is go through each base and determine if it's going to stay or go. Positive, it stays. Negative exponent, it goes. So a to the 9th stays. b to the negative 18th goes. c to the 6th stays. a to the negative 15th goes up top. b to the negative 6th goes up top. c to the 3rd stays. So now I look, my a's, both a's are up top, so I'm going to multiply them by adding the exponents. 9 plus 15 is 24. When I look at the b's, I have 6 up top, 18 on bottom. Cancel 6 out. How many do I have left? 12. And where am I 12? Down below. And then if I look at my C's, I have 3 on bottom, 6 on top. Cancel 3 out. How many do I have left? 3. And where are those 3 up top? Okay. Remember, if you're having trouble with any of this, go back and rewatch any video segment that you need to help figure it out. Hopefully this helped. Go ahead and work on the homework, and if you have any questions, I'll be here on Friday to answer.